Let's now consider the final exercise for our math review. And this one here is again for us to make some modeling decision. Remember the earlier exercise we did about determining whether it should be a relation or like a total function or partial function, about keeping track of the location for the employee in the organization's premises, right? That's that exercise. It's kind of relevant. But I would say this one is even more exciting because now we are trying to link, we're trying to formalize something you also have been doing in your earlier Java courses, the programming courses, which is about array. Let me pose the question to you. The first one, we got a series of questions for you to really answer about modeling decision. The first one here, let me pose it first, and then I'm going to give you a little bit more background beyond the first sentence so you have better idea about how we're going to build up the exercises. Should an array A declare as string array A, right? So every array, every element in the array is going to store the reference to some string objects. And let's not worry about the size. It can be arbitrary, okay? Should this kind of array be modeled or formalized as either a partial function or a total function? Let's take a look. Either we can say A is a member of a partial function between the two sets. The first set being the set of integers. Remember the Z, that's about the set of integers, including, well, basically theoretically going from minus infinity all the way to 0 and then all the way to plus infinity. And think about the string more like a set of all the string literals you can put inside the double quotes that you actually write in Java. You can think about string just all the possible strings in a particular set. Should that be a partial function from integer to string, or should that be a total function from integer to string? Right? So let me help you visualize exactly what we're trying to do over here, and this will also help you later on when we actually talk about system specification and refinements later, when we talk about different other realistic system to actually model. Right? Let me now help you a bit. Okay? Think about the string array. So we are declaring this by using string array A. Let's make it maybe size 5. How about just small? That'll be enough. String array, and let's say index 5. Let's say 5 in size. And of course, you can initialize the elements in the array. I'm going to leave that to you. Let me go directly to, let's say A is going to be a reference pointing to the beginning of the array of size 5. And for convenience of writing, I'm not going to put a double quote. I'll just put the name directly. 1, 2, 3, 4, 5 over here. Okay, let's put the element inside. So let's say we got Alan, we got Mark, and also we got Tom, and also we got Jim. How about we got Jonathan as well? Right, so we got these 5 strings stored in the array. And you can think about the array can be formalized as a set of ordered pairs. And what will be the first element in the pair? The first element may be the indices, which will be 0, 1, 2, 3, and 4. And what about the second element? It could be the values that are actually stored in the array. Alan, Mark, Tom, Jim, and Jonathan. Of course, in the special cases where the slot may just be storing null references, you can think about null maybe a special value for us to consider as well. But that's okay. Let's assume there's no null reference for simplicity. So what you can formalize first of all is as a set, and then we can determine whether it should be a partial or total function. That's something I'll leave to you. But I think the more fundamental question is, should it be a relation or should it be a function? Should it really satisfy the functional property? That's something that I didn't really mention in the slides, but I would like to discuss with you. All right. Let me now first of all put the sets. It's going to be a set. You can think about A. It can be formulated using a set of ordered pair. In this case, we got 5 ordered pairs since we got 5 elements. So 1, 2, and also 3, and also 5, right? I would like to write everything in a single line if I may. So let me put it here. 1, 2, 3, 4, and also 5. All right, the first elements are going to be the indices 0, 1, 2, 3, 4. 0, 1, 2, 3, and 4. And the second elements are going to be the actual contents. It will be Alan and it will be Mark, and also you'll be Tom, and also Jim, and also Jonathan. I'll say Jonah. Okay, it's a abbreviation. Of course, to be more precise, they should be in quote. Okay. Okay, what we're doing is, you can think about this part over here is more like a programming concept over here. This part over here is basically what you know for programming. And this part over here, which I'm going to use the green over here, this is about formulation in discrete math. All right, so we are trying to do formalization, which we do always in this course. And hopefully beyond this course, you will do that as well. It's a very beneficial way of analyzing or thinking abstractly. So this is the formulation or formalization. Let's say formalization. Formalization in math, or more precisely in set theory. All right, I'm gonna let you fill the gap over here. Right, what we're saying is, you can see index 0 stores Alan will be formalized as an order pair where the first element is 0 and then second element is actually Alan. All right, pretty good. And now here's a fundamental question which I didn't say in the slides. Should A over here be formalized or modeled? As a relation? Right, you can see the question I posed over there. I already assume we're gonna model it as a function over here, right? Is either total, just that it's either partial or total. But what about relation? I'm pretty sure you're curious about it as well, right? So now you can treat this as a question number 0. And I would like you to pause the video and think about what the answer should be, yes or no, and justify it. All right, you can now pause the video and think about the answer to this question. Assuming that you thought about it, all right, the answer should be no. It should not be a relation. Can you? If I say no, I'm gonna justify why. Because if I actually allow that to be a relation, that means it's possible for the same first element, the domain value, to map to a different range value. What does that mean? Let me take a look. Let me just show to you. For example, I might say over here, let's say a counterexample could be, because let's say I might say 0 index, I got Alan. Just another example. And also I got maybe 0 index, I maybe got Jin. So what does that mean? That means the same index can store more than one string value. That's not consistent with the way we understand about what's happening at runtime. It's not possible to store more than one values at the same index of the array. It's simply not possible, right? So that's why it is not appropriate. Okay. In reality, only one elements, I should say maximum one, because you may not store anything, but let me say only one. Only one elements may be stored at each index. But by modeling A as a relation, over here is a relation in this case, what's a relation? So when I say relation, I really meant something like it's going to be a relation between an integer, right? That's the integer, and also the string. This will not be appropriate because we will allow some satisfying set, or what, we will allow some member set, which is a relation over here that will actually correspond to the same index storing different values. That's definitely not making real sense. All right. So make sure you understand the idea over here as well. Okay. And let's now not only got an idea about how we can formulate this array over here as a function, right? Meaning that every index, like a domain value, can store at most one string. But the question is, should it be partial or total? Always have this kind of visualization in mind, and then you will be ready to answer all the questions. Okay? All right, okay. Let's now take a look. Should it be a partial function or should it be a total function, right? Okay, now pause the video and think about this particular question over here, right? Well, okay, assuming I thought about it, it should be a partial function. How can that be a total function? If you're really struggling with this, that might mean you really have to go back earlier to really review the relevant parts about total function and the exercise we did earlier. What does it really mean when it's actually total function? If it was a total function, that means the indices, well, the set of indices should be equal to exactly the set of integers, which include negative number and also very large positive number that's towards infinity. But realistically, all the array indices is only in a particular range from 0 until a.length minus 1. So that's why it cannot be a total function. It's simply not possible, right? So that's why it should be a partial function over here. All right, and I explained it over here exactly, right? You can read it through. All right. Exercise number 2. What does it really mean if an array is actually modeled or formalized as a partial injection? Well, we know that it should be a partial function. It cannot be a total injection. Of course, it cannot be total. Again, the set of valid indices of any array should be, number 1, finite, and number 2, larger than or equal to 0 for sure. So that's why the set of integer cannot be the domain and also be total on this particular integer set. But the question is, if I tell you that, well, remember the tell over here, right, for the symbol, right? If I say an array can be formalized as a partial injection, what does it really mean over here? What does it really mean? Well, let me actually, this is actually a partial injection because every element over here that is actually stored corresponding to the second element, there's no duplicates over here, right? What does it really mean when it is not a partial injection? Okay, let me just give you another example of it. I already answered that exercise, but let's say give you one example where it's not a partial injection. Let's say not partial injection. How would that array look like? Well, just give you a simple example right away. Let's say A is simply an array of size 3 over here. Maybe it is that Alan appeared twice. And we got Jin maybe in the middle. So let me write better. Okay. All right, you can see over here, Alan and Alan, right? So it's like having 2. Well, if you think about the corresponding pair, right, it's really important for you to understand this. So if you think about it, A is simply equal to 0, 1, and 2, right? 0 to Alan, and also 1 maps to Jin, and also index 2 maps to Alan again, and close the set, right? Alan and close the set. Now you can definitely see some duplicates of the value. You can see Alan over here and also Alan over here, but their corresponding indices 0 and 1, 0 and 2 are not equal to each other. That's exactly how we judged when the function it cannot be is not injective, right? So if I say an array is actually a partial injection, that means all the elements stored inside must be unique. There should be no duplicates. Programmatically, it is definitely possible for an array to have contain duplicates, but under certain circumstances, maybe you don't want your array to be containing duplicates. In that case, you want to specify it should be a partial injection, right? In that case, you definitely have to prove about its injective property, right? It's a very important concept over here. All right, so that's exactly what I said over here. Exercise number 2. Number 3. Can an integer array, let's talk about another type of array. A will simply store integer. Can it be a partial surjection? Again, being a total function is not possible, so that's why I'm only talking about partial, right? Can it be a partial surjection from integer to integer? All right, you can pause the video and think about it. What's really the essence for having the function being surjective? Well, you can see the double-headed arrow over here, right? That means we're focusing more on the range, right? That's the hints I'll give to you. All right, assuming that you thought about it, In order for the function to be surjective, that means the range, the range of the array, meaning that all the elements that are actually currently stored in the array will actually equal to exactly this particular integer over here, right? Also, it depends on how you interpret this particular set over here. If you want to interpret it as the theoretical integer, in that case, no, because you cannot store plus infinity or minus infinity in the array. But let's say, let's relax that restriction a little bit. Let's say the z over here is simply the int, integer type in Java, right? In that case, it would be possible, right? Let's think about why, okay? Conceptually, you can think it this way. So, partial surjection. Surjection. Let's say it's going to be from z, and then it's going to be a partial function over here, and then it's going to be double. It's going to be a partial function and double headed arrow over here, right? And let's relax the constraint that maybe this part over here simply corresponds to the int data type in Java. Of course, in the test or in the exam, I'll make it explicit to you if it's really the z really means the integer type in Java. All right, what does it really mean? It means the following. So that means you got an array A, which will go from index 0 until a dot length minus 1. So 0, 1, all the way to the last index, a dot length minus 1. And the range of the array being a function would be all the element that's being stored. For example, over here, all the elements being stored in the array. So that would be simply about what's really stored over here. Let me just be careful. What's really stored here, what's really stored here, everything that is stored in the array. As long as you have already stored all the possible integer that's contained in the integer type, right? And if you recall your Java knowledge, the int data type is 32 bits integer. And if you look up the official definition for the integer type in Java, which I include in the slides for you, it's going to be from, in this particular inclusive range, from minus 2 to the 31 all the way to, well, including 0 and then 2 to the power of 31 minus 1. So that'd be that many integers. If you really create such a big array, and somehow it happens to store all these integers, all the 2 to the 32 bits integers, 2 to the 32 possible value for the integer type, in that case, yes, it could be surjective. All right. So that's my point over here. All right. Again, it's very important for you to know when you formalize an array as a function, you want to make sure you know that domain means the indices. Okay, let me just make one more thing over here. You can think about this part over here. The indices are the domain. Okay, let me just put over here. Let me put better. Okay, so the indices is formalized as, I'll just say approximately close to the domain concept. Domain. And the ranges over here, let me use pink over here. And the range, all the element that's being stored in the array, so these are like a contents of the array. So they are the range. So the contents of the array, or the elements in the array, is the range. All right, that's something you want to be very clear about. All right, we got two more. Number 4, can a string array over here be formalized as a partial surjection? So now we talk about string rather than integer. All right, so that will be how you write it. And let's still make the assumption that the z over here is the integer data type. It doesn't matter. Okay, so let's say just an integer over here. Okay, and then partial function for sure, but can it be surjective? We said it was possible for this to be for this integer array to be surjective if it store all the possible value for integer. That's my hint to you. How about this one here? Can it be a surjective function where the range is a string? All right, so you can pause the video and think about it. The answer is no. If you think about it, the number of possible strings you can ever have is really unbounded, right? So how do you numerate them? For example, you can numerate all those possible string value by their length, right? So you can start with, so when I talk about strings, you can talk about based on the cardinality. For index 0, for length 0, it will just be empty string. For length 1, already, you can see you're going to put one single character over here. You got so many characters that can be typed from your keyboard. And also, if you got 2 over here, you're going to get 2 places to fill in. And each one of them can be any character that can be typed from your keyboard, right? So if you think about the size of the string is really unbounded, they're only bounded by the memory of your computer. But you can pretty much say in today's world, it's unbounded, right? So I would say it's definitely, you can almost think of the all the possible strings that you can ever write will be infinitely many. In that case, it's simply not possible to have an array that can store all the infinitely possible string values into the contents of the array. It's not possible. All right. So the answer is no. The final question over here: can an integer array over here storing all the 2 to the 32 values, pretty much like this, right? Let's say the array actually store all the values that's really specified in the int data type. Can it be modeled as a bijection? All right, bijection over here. And think about the very definition for bijection. And then you pause the video and give me the answer. Well, what's the definition for bijection? Well, I'm not telling you the answer. So if you want to pause the video, you should really pause it, right? All right, that's all the answer. Bijection, by definition, is going to be total. It's going to be total and also injective and also surjective, right? Let's only worry about the part about total. We already said that it is not possible for the array to be formalized as a total function. It's simply not possible because the range of the indices is simply finite and also only contain larger than or equal to 0 range. In that case, it will already violate one of the criteria for being bijection because it cannot be total. So no, because well, exactly what I just said, it cannot be total. All right, it's a very, very important slide over here to just conclude our math review. This kind of a modeling decision about like a choosing which kind of a function or relation or what kind of function relation to really formalize your programming variables or specification variable is a very common activity you will have to do, and also very frequently you have to make such decision. You have to know which one to choose, number one, and also you have to know how to justify it, whether to use or not. All right, so that's about the math review. I think we spent about 2 weeks doing this math review. I believe it's worthwhile because we really try to link your math, the math that you knew about, or maybe now you know about, to what you're familiar with about programming. We try to connect the two worlds, which you didn't do before. The final slide is about beyond this lecture, what should you study, right? And I would suggest, number one, remember that where is exercise over there in the earlier slide when we talk about total versus partial function. You may not want to think about what does it really mean when we already said in the earlier exercise that where is should be a function, should be a partial function. That's already said. But what does it really mean when the function is also injective? What does it really mean when the function is actually surjective? And what does it really mean when the function is actually bijective, if applicable? All right. Second exercise you may do is, since I can only cover a limited number of examples and exercises in this math review lecture, however, I would recommend, I will encourage you to really go back to your earlier math courses to find out any additional examples. And if you got any trouble finding them, I think you can reach out to me. Maybe I can point to you some other references, right? But I can just Google. All right, you can ask questions in the Q&A to really clarify all the concepts that we have reviewed. There might be more that we will need mathematically to really model the system and also refine them, but we'll actually talk about them just in time whenever we need it. But I think this will be whatever we have done so far will form a very good foundation for you to move on with the course. All right, that's about it for the math review. And starting from the next lecture, we will actually start talking about the case studies of modeling and also refining system across the various application domains. That's what we will do. All right, stay tuned, and then I'll see you soon.